sidewalk, take away the pain. I see sparks fly whenever you smile. Get me with those. What's going on, YouTube? We're back today, Mr. Palmer's Honors Chemistry, with our precipitation reactions. We got two problems lined up together. We're gonna do two together, and then we're gonna do two alone. Alright, so let's get this shit started! As you can tell, I'm just really a big lover of chemistry, so that's why I'm so hyped. Yep. Okay, so aqueous solutions of potassium bromide and silver nitrate. So it's already telling us these are aqueous, dog. You don't even gotta check, bro. These are aqueous. So let's get started. Okay. Yeah, let's get started. Okay, so potassium, bromide, aqueous, plus silver nitrate. Gotta remember what the fuck nitrate is. It's NO3, right? I already knew. I didn't need to check, but I did. NO3. That is gonna make potassium nitrate plus silver bromide. Is that a thing? Silver bromide? I just checked. Yes, it is. So now we just gotta balance our equation. Just found out it's actually already balanced. So basically, we know that these two things are aqueous. And it's like, well, what the fuck? Like, what am I supposed to do about these? So we're going to go to our solubility chart. Here is our anions. Here's our cations. So let's take a look at our anions. Let's look for NO3. And it's soluble in all. So this is going to be aqueous. If it's soluble, then it's aqueous. It's dissolved. And then silver bromide. So let's look for bromine. Bromine. And it's not soluble in silver, so this one is going to be a solid. If it's not soluble, it's a solid. It's sitting like at the bottom of our test tube. So if we have our precipitation, we have to do our molecular equation, which is this. Someone's calling me. Stop it! All right, my molecular equation. We need to do our ionic equation, and we need to do our net ionic equation. So the ionic equation is just everything spread out. So let me just show you what I mean by that. So we're going to do potassium, and we need to do the charges as well. So plus, and it's aqueous, plus bromine, aqueous, minus, plus silver, which is plus, and it's aqueous, plus our nitrate, and that's aqueous, and minus 1, plus, oh, not plus, we need to draw a little arrow, and that's going to make our potassium plus, and that's aqueous, plus nitrate, minus aqueous. And once we get to our solid, we don't split that up. So we're just going to write silver bromide solid. And we don't need to write our charges or anything. So that is our ionic equation. Sorry if it's not legible. I'll do the next one better. But now we're going to cancel out both sides of the equation. So this is the half of the equation. We have our aqueous potassium on both sides, so we can cancel that out. We have our nitrate on both sides, so we can cancel that out. And then we just have our net ionic equation, which is going to be bromine. Sorry, why did it not focus? Plus silver. Oh, I forgot to write the little charge. And also, I'm like looking at the camera while I'm writing this, so it's like really difficult. So sorry. And then that's going to yield our silver bromide. There we go. That's our net ionic equation. So aqueous, iron chloride, and sodium carbonate react. Okay, so aqueous, iron chloride, and sodium carbonate react. What are they going to do? Okay, so iron chloride plus our sodium carbonate. I did it like all slanted. I'm looking at the camera, so it's like really, like this is like a real challenge in my life. And these are both aqueous, so we're going to write our little aqueous. I think they're little aqueous people. Are going to make iron carbonate. Sorry, I already know that it's a solid, but I'm going to like check with you to show you like how to do it again. Okay, this is our equation. I'm going to balance it. BRB! Now that our equation is balanced, let's see what's solid, what's aqueous, whatever. Okay, so iron carbonate. So let's look for carbonate, which is CO3. And so that's all group 1A ions plus ammonia is soluble. So all others, we're not soluble. We're a solid. We're not soluble. And then sodium chloride, that's salt. We already know the answer, but let's just check anyways. All others soluble. Yeah, we're aqueous. We're feeling it. We're aqueous. So now this is our molecular equation, and now we need to do our ionic equation. So let's do it. Let's get to it. Okay, so we're gonna do 2 iron plus 6 chlorine, plus 6 sodium, plus 3 carbonate is gonna make 2 iron plus 3 carbonate. Here, I'm gonna go into the parentheses. Fuck. I just made a mistake. A grave mistake. And hopefully you caught it. Iron carbonate is our solid. Do we split up our solids? No, we do not. No, we do not. Never split up your solids. So you're going to do 6 sodium plus 6 chlorine. And then we're going to write all our charges. So plus 3 minus plus minus 2. No charge for that. Plus minus. And then do our aqueous thing. Aqueous. Solid. And we do not split up our solids. Aqueous. Yeah. So now it's time for our net ionic equation. And we just need to cancel out. So we have 6 sodium on both sides, 6 chlorine on both sides. So then it's just going to be 2Fe plus 3 aqueous plus 3 carbonate aqueous is going to make our iron carbonate, which is solid, and that's our net ionic equation, and this is that solved. Yeah, gonna make an equation for you to do on your own. Aqueous solutions of ammonium chloride react with lead to nitrate. You're getting your answer in 5, 4, 3, 2, 1. Here's the answer. There's ammonium chloride plus lead nitrate to make ammonium nitrate and lead chloride. And then there's our ionic and net equations. I just put the cross when I was canceling them out to do the net ionic equation. There it is. We're going to do one more problem just for you. All right. Sodium phosphate and calcium chloride react. 5, 4, 3, 2, 1. The two things made sodium chloride and calcium phosphate. And calcium phosphate was our solid. Here are our ionic and net ionic equations. And there we go. There's your answer. And I hope you have a good day. Okay, have a great day. If you have any questions, just let me know. Hit me up, okay? Make sure to like and subscribe and follow for more chemistry in the future. Perfect face. Okay. Bye.